In this example, we're going to do a hypothesis test traditional approach for two population means when the population variances are unknown and assumed equal. So in this example, a manufacturer claims that the watt usage of its 17-inch flat panel monitors is less than that of its leading competitor. Is there enough evidence to support the manufacturer's claim? And we're going to assume that the populations are normally distributed and the population variances are equal. And we're going to use a 0.05 level of significance. So we see we have a first group, we're going to call it the manufacturer group. So any subscript we're going to label as the first group. So N1 is 12, S1, the sample standard deviation is 2.4, and the mean we're going to call X bar 1 for that first group is 73. For the competitor, we have the second group, so we're going to label that the sample size of the second group, N2 is 15. S with the subscript 2 is going to be the sample standard deviation of 3.2, and the mean of that second group, we're going to call it X bar with a subscript of 2. So that is identifying our given information, and of course we have the level of significance of alpha is 0.05, so that's what we're going to do in that first step. In our second step of our template, we're going to identify the claim, write the null and alternative hypothesis, and remember the null hypothesis must contain equality. So as we look at the claim, it says the manufacturer claims that their flat panel monitors is less than that of its leading competitor. So we have the mean of the first group, that manufacturer mu1 is less than that of its competitor mu2. So we can write that in the alternative hypothesis because it doesn't contain equality, and then we have mu1 is less than mu2, or the difference between them is less than 0. That's our claim, and our claim number is 0. We're going to need that in step number 3. The opposite of less than is greater than or equal, and the null hypothesis also does contain equality then. So these are always opposite symbols of each other. So we have mu1 is greater than or equal to mu2, or the difference between them, mu1 minus mu2 is greater than or equal to 0, and in the alternative is where our claim goes. In step number 3, we're going to calculate that test statistic. Now we have a claim about the mean, mu, but our population standard deviation, sigma, is unknown. We know S1 and S2, and we're assuming that the population variances are equal. So now we have to use this formula. It looks a little bit intense, a little bit of a calculation here, but we're going to calculate using a t-test statistic. So we're going to use the t-tables in the future steps of step number 4. We're going to take X bar 1 minus X bar 2 minus mu1 minus mu2. That's our claim number. That's where we get that. And X bar 1 was 73, X bar 2 is 74. So the difference between them is a -1, which is okay in the numerator. Now we have this pooled variance. It's called SP squared. You'll see it in the denominator within that square root. And that formula is taking N1 minus 1 times S1 squared. So we're taking the variance of the first group, and N2 minus 1, and we're taking the variance of the second group. So you'll see 12 minus 1, that's the sample size of the first group, minus 1, times 2.4 squared, plus sample size of the second group, 15 minus 1, times 3.2, and then square it. And then doing that calculation, we're going to divide by N1 plus N2 minus 2, or 12 plus 15 minus 2. We get this calculation here of 8.2688. We're going to fill that in. Now that's already SP squared, so we don't have to square it again. So we're filling it in exactly as it is. We're dividing it by N1 is 12, and then doing the same thing for the second group where N2 is 15. Doing that calculation now, adding these two fractions together and then taking the square root, I get 1.113696548 in the denominator, and we're going to take -1 divided by that. I'm going to end up with a test statistic of -0.90. So that's my test statistic. We're going to need that in future steps. Then we're going to identify the critical value or critical region, rejection region, in step number 4. Now first we got to decide if it's a one or two-tailed test. I'm going to look at the alternative hypothesis of that. It looks like it's a one-tailed test pointing to the left, so I'm just going to shade in that left side of that left tail. We're going to put in all of our level of significance in there, and the degrees of freedom for this test statistic that we use is N1 plus N2 minus 2. We had already calculated that out in the denominator here, and we got 25. So we're going to use the degrees of freedom of 25. We're going to use our t-table, and we're going to pull out out negative 1.708 using our level of significance of 0.05. So we get a negative 1.708, just a one-sided test on the left there. So our rejection region is just what we shaded, written in symbols, t less than negative 1.708. In step number 5, we're going to determine if our test statistic falls in that rejection region, and if it does, then we're going to reject HO. If not, then we're going to fail to reject HO. So we got to look at, in step number 3, that negative 0.90 and determine where that falls. So negative 1.708 lies here. So clearly negative 0.90 does not lie in that rejection region. It would lie somewhere over here. So we would decide to fail to reject HO. So making our final concluding statement, we would make that statement of fail to reject HO. Since I'm failing to reject HO, it's like I want it, but my claim is not there, so I can't have my claim. So there is not sufficient evidence at alpha is 0.05 to suggest that the watt usage of its 17-inch flat panel monitors is less than that of its leading competitor. We're just restating that claim then.